Welcome back to Calculus 1. In the last video, we saw how we can use this new concept of the limit to find values that functions appear to be approaching even if the function is not continuous. This process works fine for many different types of functions, but we saw the limit fail in two different instances. Thankfully, there are still some operations we can sometimes perform to derive at least some sort of conclusion from these limits that does not result in a D&E. These are called one-sided limits. As we can infer from the name, one-sided limits are only concerned with one side, either the right or left of a function where the x is approaching some number. There are two types of one-sided functions, right-handed and left-handed. Right-handed limits only look at a limit from the right side of the function. Left-handed limits, on the other hand, deal with the limit on the left side of the function. Let's look closer at how these different limits are denoted. Here's a regular limit. There's only a small difference between the three. Notice how the one-sided limits have a sign next to the number in the limit. The right-handed limit has this plus sign above the number, whereas the left-handed limit has a negative sign above the number. The way we can remember this is by thinking the plus sign on the right-handed limit is telling us that we're approaching the function as if we're coming from positive infinity. Then we'll think the opposite for the left-handed limit. The negative sign is telling us we're coming from negative infinity. Let's look back at some previous functions to see how we can use one-sided limits. Here's the step function where x value is less than 0 returns 0, while x value is greater than 0 returns 1. Recall that the limit as x approached 0 gave us a D&E because the two arrows never reached the same position. Well, with one-sided limits, we only get one arrow, so now we don't have to worry about both reaching the same spot on the graph. Now let's see if we can find the right-handed limit as x approaches 0. The plus sign indicates we'll approach the function from positive infinity, and as we do so, the arrow reaches just next to the 0, and shows us that the right-handed limit is equal to 1. Now let's find the left-handed limit. Again, we'll look at the sign of the limit. The negative sign indicates we'll approach the function from negative infinity. As we follow the arrow, we'll see it settles at a point slightly less than 0, which indicates this left-handed limit is equal to 0. At the beginning of the video, I mentioned the function sine of pi divided by x. Unfortunately, we still can't derive any sort of conclusion from a limit even with one-sided limits. Let's check anyway just to be safe. We already know the graph won't show us anything new, so let's go straight to the table. Let's just look at the right-handed limit as x approaches 0. Even when the inputs are super tiny, the outputs still don't seem to settle at a single value. So, sadly, this limit still does not exist. Let's look at a different example where one-sided limits become useful. Here, we have a more complicated piecewise function that includes three separate functions and a point. Let's first focus on the function at x equals negative 3. Here, the function is not continuous, so I want to find the right and left-handed limits at this x value. When looking at the function as x approaches negative 3 from the left, the arrow approaches a y value of negative 0.75. Now we'll see what the limit is as x approaches negative 3 from the right. The arrow now stops at a y value of 3. And remember, we simply ignore this dot here since we're only concerned with what happens around the x value we're approaching and never what actually happens there. Let's continue finding the limits at the other instance of discontinuity. Let's find the limits to the left and right of x equals 2. When approaching from the left, the arrow rests at y equals 3. And when we approach from the right, the arrow stops at y equals 0. And there we have it, all one-sided limits for this function. That's all for this lesson on one-sided limits. I appreciate you spending this time with me learning this beautiful subject. If you'd like to see more Calculus 1 videos, leave a like, comment, or subscribe to keep up with the happenings on this channel. Goodbye for now, and I'll see you in the next lesson.